Hello and welcome to another Java tutorial. In this tutorial, I'm going to continue our discussion on Java native interface and look at a very important topic, which is how to work with Javap. So Javap is also a binary tool that comes with JDK, similar to Java Edge. So Javap is a tool that comes with the JDK. It allows disassembling class files, binary files, right? Class files are compiled version of the Java files, right? We take the source code, which is inside a .java file, and then the Java C compiles that source file and creates a .class file, right? Which is the binary files into a human readable format. So when we run Javap on a class file, again, just very similar to Java Edge, Javap also runs on class files, right? So we feed the class files, the binary Java files, to Javap, and it gives us a human readable format for that class file, right? We typically use verbose mode -v with Javap, so it's Javap -v and then the class file. Similar to Java Edge, it acts on class files, compiled binary, and not Java files, source text, right? So the difference here is that a class file, it's a compiled binary, right? A Java file, which has .java extension, is actually the source file, the text file, the textual representation of the class, and then a .class file is a compiled version or a binary version of that class, right? Some binary format that JVM understands. It is useful for finding the signature of a native method. So again, for Java Edge, when we run it, it creates the header files, right? So it's mostly automated. But let's say if we want to call a particular method in C++, when we are developing JNI applications, we have to know the signature of the methods inside a particular class. So Javap can be very helpful in that case, right? Signature is called descriptor in the output of Javap. So when we have a method, the descriptor of that method is actually the signature that we need in Java, in C++ when we want to call that method. Now here's an example. Let's say I have this package test33, and inside that I create a person class in Java. So package is test33, and then I have this person class. It has a name and age. The constructor takes the name and age and then assigns them or initializes the name and age, and then I have this native method, public native void print info, right? So we know that the constructor is a special method, which in bytecode it's called init in diamond brackets. And then if I want to create a new person object in C++, I have to ask JVM to create a new person. So it has JVM has a method called new object, but then I have to pass in basically the signature of the constructor, because Java allows constructor overloading. So I have to tell JVM in C++ which constructor to call. And for that, I need to know the signature of that constructor, right? So if you look at the output of the Javap, when I run it on the class file, the .class file that corresponds to this person class, it tells me this constructor test33.person has a public access modifier, and it takes a string, java.lang string, and int, right? But this is not the signature. The signature that I need in C++ is actually the descriptor, which tells me that for a particular method, know that constructor is a special method. And the descriptor of the method is it's the signature of the parameters in round brackets and the return type. For a constructor, the return type is always void, all right? And here again, inside the JVM, the path separator is /, not dot. Dot is only inside the Java source file, right? As long as it goes into the class file and then the JVM, there is no such thing as dot. It's all /, right? So L semicolon is telling the JVM that it's an object. It's a signature of the object, and then this object, the first one is a string, which is a Java /lang string. The second one is a primitive integer I, and the return type of the constructor is void. So if I want to specify the signature of this constructor in C++, I have to use this descriptor, all right? Not the actual java.lang string. So it's not dot, it's L semicolon for signature of the objects, and then the path separator for objects is /. Same thing for this native method, print info. So I have this public native void print info. This is the output of Javap. And then the descriptor is it takes no parameter, so round brackets, it doesn't have any parameters, and the return type is void. And again, the descriptor is the one that that gives us the signature of the native method that we need in C++. And it also has these flags that tells us access public. It's public access modifier and access native, so it has a native access modifier. Same with constructor. Constructor has a flag which is access public, so it's a public constructor. All right. So how do we set it up in Eclipse IDE? So here I have created this Javap tool, right? Now obviously we click on this new button in the external tool. So we have to run it as an external tool. So that's why we have external tool configurations in Eclipse. We create a new one. I just call it Javap and point it to the binary file of Javap inside the JDK. So let's say Java virtual machines, the JDK I'm using, contents, home. In the bin directory, I specify the Javap. All right. So create a new external tool, give it a name, point it to the Javap executable. And then again, very similar to Java Edge, Javap also acts on binaries. So working directory must be set to the root of the binaries in our Java project, which is the bin folder in Eclipse. If you are using Maven, if you recall when we set up this Java Edge-Maven external tool, in Maven all the class files are inside the project name /target/classes. So if you're using Maven, you have to set it up based on the target/classes, not the bin directory, right? So point it to Javap executable, set the working directory to the root folder for the binaries, the class file binaries. For a regular Java project, it's the bin folder. For Maven, it's target/classes. And then here we can use any of the flags that the Javap accepts. Here, for example, I write -v, right? -v. So I'm running Javap on a class file with this flag -v, and then Java type name. And again, similar to the Java Edge, when we set it up, Java type name in Eclipse means the fully qualified name of the .class file, right? Not the .java file, .class file, Java type name, right? If we want to run a tool on a .java file, we have to specify a Java resource, right? Not the Java type name. Java type name means the fully qualified class file. That's why we point the working directory to the binary, the bin folder. And unlike Java Edge, Javap was not deprecated going from Java 8 forward, so it's also available in JDK 9 or later. Note that Java Edge was deprecated in JDK 9. I don't know why, but Javap is still there. Javap again acts on binary files, class files. -v is the verbose, can be set to generate a verbose result, right? So what are the parameters or the options that the Javap can work with? So Javap syntax is in the terminal we write Javap and then we specify the options and the class name, right? Again, class, the fully qualified name of that class. So -help or basically this should be -- help or question mark prints a help message for the Javap command. -version prints version information of the Java. -v or -verbose prints additional information like stack size, number of locales, and arguments of the methods. So if I go back here, you see when I run Javap on this person class with the -v flag for verbose, it also prints these flags. Access modifiers also tells me the stack, local variable table. It prints a lot of information. It also prints the constant pool, etc. -l prints line number and local variable tables. -public prints only public classes and members. So let's say I want to just look at the public members, not the privates. So I can just use the -public. -protected prints protected and public classes and members. -package prints package, protected, public classes and members. So package access, prints when we use -protected, it prints only the public members and the protected members. When we use -package, it prints the package level access method that have only package level access, which is the default. the protected access and the public access. And we also have the hyphen private, which means it only prints the private ones. Hyphen C prints disassembled code. Hyphen S prints internal type signature. And actually this is basically the descriptor, the method descriptor, right? Internal type signature. Again, internal here, it means that it's the internal representation inside the JVM. And again, unlike Java, I say it again, internal in JVM, there is no dot separator. It's all forward slash, right? So this hyphen S is actually what is only printing the descriptor, right? So this is what we typically need for JNI development, because this prints the signature. Internal signature is basically the descriptor of the methods or fields. Hyphen sysinfo prints system information, path, size, date, MD5 hash of class being processed. And hyphen constants prints final constants of the class. These are like public static final fields, right? The compile time constants. And if you want to look at some examples of these flags, you can go to this website. It's a very nice article, www.geeks4geeks.org/javap tool in Java with examples, right? So you can all these flags are basically explained there with some examples. But here I'm just going to fire up the terminal. Let's see which javap my path environment variable is pointing to, which javap. So it's in JDK 8 and then contains home bin javap, right? So I'm using the javap from this JDK. And let's see, javap hyphen help. So it prints the information, all the flags that javap can work with, all these options. So the usage is javap, the options, and then the classes. So it can act on one class or more than one class, right? Where possible options include hyphen help or hyphen help or hyphen question mark, all right? Prints the usage message, prints this information. Hyphen version information, hyphen v or verbose, additional information. Hyphen l is the line number and local variable table. Hyphen public, hyphen protected, hyphen package. Hyphen p or private, show all classes and members, right? Even the private ones. Hyphen c, disassemble the code. So if we give it, it gives us the disassembled Java code, right, for that particular class file. Remember that the class files are binary files. Hyphen s, print internal type signatures. Hyphen sysinfo, show system information. Hyphen constants, and a few other for class path. Hyphen cp. And when we set up the external tool in Java, in Eclipse, these flags are automatically set, so we don't need to worry about them, right? But if we run from the terminal, we have to also most likely set this class path, right? And this class path is basically this working directory. That's why we point the working directory to bin, and then when the external tool in Eclipse runs the javap, it automatically uses this cp, the class path flag, to the bin directory. And then when we use the Java type name, it adds the fully qualified name, right? Package.class, right? So what I'm going to do here is let's see, java hyphen sys javap hyphen sysinfo, no classes specified, so this is sysinfo, but I can use, for example, java p hyphen version 1844. Basically this tells me that this Java P is from the JDK 1844. Again, I can use which Java P to see where my bash terminal is getting this Java P binary or executable. It's from the JDK 1844, right? So you can have multiple JDKs depending on which JDK is in your path environment variable. You can use different Java Ps that come with different basically JDKs. So let's head to Eclipse and try to run the Java P on a class. So I have created this package test33, and in that I create this person class. And again, it has two fields, a string and integer, and these are default access modifier, right? And then a string name, the constructor, and a native method, right? So if I go to my external tools, I have set up this Java P. So this Javap, it's pointing to the Javap of one of my JDKs, and the working directory is the bin. And again, when we set it, when it runs the Javap, it's also specifies the hyphen class path or hyphen CP and points it to the bin directory as the working directory. And then right now I'm running with hyphen V verbose and then the Java type name. This is the fully qualified name of the class file, right? So let's close this. So I select the Java file that I want to run the Javap on it and run it. And now let's maximize the console. You see it's a very verbose output, and basically what happens, it tells me which class file was run with the Javap. It's the bin folder test33 and then the last modified. This is the last modified time for this class, and then md5 checksum, and then compiled from the source code. What was the source code? And then public class, and this is the description of the class itself, right? And it's a very verbose description. So the minor version, major version, this is Java 8, and the flags for this is public super, right? It has basically also the super class. It's a derivative from a super class, which is object in this case. The constant pool, don't worry about this right now. And then we have a Java lang string name. This is a field, and this is the descriptor. So if I want to access this field in C++ using JNI, its descriptor is okay, the name of the variable is this name, but its signature is L Java/lang string semicolon, right? This descriptor is the one that matters when we work with JNI in C++. Int age, the name of the field is age, and the descriptor is I, right? And it doesn't have any flags. When it has no flags, the access is just the default or package level access. And then the constructor, the descriptor is, it takes two parameters, L Java/lang string semicolon. It's one Java object and one primitive, which is integer, and the return type of the constructor is always void. It has a flag, access public, and this is the code. This is the actual byte code. A load 0, load a object reference, which is this, because constructor is never static. So the first parameter is implicitly a pointer to or a reference to the class itself, which is this, right? And then invoke special, which invoking the constructor of the super class, and then a load 0, a load 1, put field, and assigning the field the name, and then I load, loading an integer, put field, assigning the age, the value of the age, and then return. And these are the line number tables, line 8, 9, 10, 11, and this is our native method. And this is the descriptor, and again, the descriptor is what we need in C++ when we want to call this method, right? The name of the method and its internal descriptor, which it doesn't take any parameters and returns void, and also prints the source file, right? So this was the verbose run. So let's see if we just run it with other simpler flags. So for example, instead of -v, I just say -s, apply, close, and then let's run this person class. Now as you can see, it just prints the name and the descriptor, right? And the descriptor is what we need in C++ when we are developing with JNI, right? So basically the idea here is that I need to know the name of the field or method or whatever constructor and its descriptor. And again, descriptor is the internal representation or internal signature. An internal signature is the signature that is inside the JVM, and in JVM an object, the signature of a Java object starts with L, ends with semicolon, and its full class path, and the class path separator is a slash, /, not dot, right? That's why in the descriptor a Java object like a string starts with L, ends with semicolon, and its full class path, and then instead of dot we have /, right? So this is the descriptor. This is the internal representation of a string object, right? The type, internal type signature, internal type signature. Basically it tells JVM where this signature, where this type is. A type can be a primitive type like integer, or a basically a Java object like a string. All right. So now let's try to disassemble that binary file. Note that when I run JavaP, when I select this .java file and run JavaP, this JavaP actually is running on the binary format, the compiled format, the .class file of this person class. It's not running on the Java file, right? It's running on the .class file. So let's select this and then go to our external tool, and let's run with -c. -c tries to disassemble the binary. All right, so this is the disassembled version. Java lang string name. So as you can see, this source file is name and then int age, right? And then the constructor, we have a native which doesn't have any body, and then this person, right, takes two parameters, java.lang string and integer, and this is the code. But this is not the actual Java code, it's the bytecode, right? So this is very good when we want to learn more about the bytecode and how the source code of a basically Java that we wrote, how does it translate into a bytecode? What's the actual bytecode that is generated? So we can write javap -c to see the actual bytecode. It doesn't have any other noise like the descriptor or the stack or whatever. It's just pure bytecode, right? And this person again loads a reference which is to this pointer, this class, right? So the first one loading a reference which is this, invoke special. We know that the very first thing that happens in the constructor is a call to the super constructor, which is the object, and then it loads a reference which is the string name, and then another one, and then put field a string, and then load an integer, put field, and then return. So it just calls the super class constructor and then assigns the string name and integer I and return, right? So this is the entire concept of JavaP. And again, if we want to use it for Java development, I use the bytecode view in Eclipse. It's a plugin that you can install. And then, for example, when I click on this constructor, and then I wanted to focus on just whatever I highlight. So if I click on the constructor, you see that now it tells me its bytecode, the signature is init in diamond brackets. Its descriptor is this one. It takes two parameters. One is the L java/lang string semicolon and then an integer, and the return type is void. A load 0 and then invoke a special object init, which is the constructor of the object class, and then a load 0 1 put field a string, and then a load I load 2 put field age I integer, and then return. Local variables, we have this pointer, this reference, name, which is a string, and age. So we have 3 local variables, max local 3, max stack 2. So I typically use this, and it can quickly give me the signature of the methods. For example, print info. It doesn't take any parameters and returns void, right? But I believe this plugin doesn't work well with Java JDK 9 or later because some changes happen in the bytecode. But you can always run quickly configure JavaP and run it to see the signature of the methods that you want to use. And in order to see the signature, the easiest way is to use -s with the JavaP so that it can just give you the signature of the methods. It doesn't print other noises. It's just what is the field, what is its internal type representation, which is a descriptor. And again, this is what we need when we use JNI, right? In C++, this is what we need, right? So I hope you enjoyed this lecture. Please stay tuned, and I'll see you in the next one.